Today I'd like to welcome Tim Liescheidt to discuss and meet with me. This is a very informal conversation. We're just going to go over some questions, really for younger people like myself and for anybody interested in the industry, just to learn more about your work with especially the profile that you and your team pioneered, the AdvanT style truss and the corresponding T-shaped profile. So, but let's take it a step back, and Tim, I want to just ask you, tell us about yourself. Like, what's your experience in the industry? What's your experience with truss fabrication? Tell us about that.
Okay. Well, first off, I'd like to thank you for letting me be a part of this. I think it's really, really cool seeing what the younger generation can bring to our maybe industry full of aging people. I think it's going to go a long way to helping us be current, helping us to stay on the front end of everything. So thanks for that. So my background, if we start way back at the beginning, after I graduated as an engineer, was looking for a job, and there was a company that was headquartered really right across the street from where my dad worked. Had no idea it was there. It was called MyTech. Big sign on a building. I think I probably drove by it 1,000 times and didn't have any idea what it was. When it was time to look for a job, I sent a resume and was hired on there, reviewing wood truss designs using the whatever version of the MyTech software we used back then. So I started out there, worked in the wood truss review for however many years, 2-3 years, and then they had an opening in their research and development department, which was in a different part of the city. In their manufacturing plants where they made equipment, and this opening was to be an engineer, so similar stuff that I was doing on the wood side, but for their new product which was metal framing, and it was still part of the research and development department way back then. So I took that opportunity and moved over, and that's how I got started in cold form steel. That was my introduction to cold form steel. It was brand new for a company that really had pioneered wood trusses, and they were dipping their toe in the steel truss market. And by really just being in the right place at the right time, or I guess some might say the wrong place at the wrong time. Anyway, I got that opportunity and got to work in that little division. It was kind of funny. I can remember wood trusses had been around, I guess, for quite a while, the connector plate business, and there was basically an answer for every question that I had. And I can remember it was probably in the first couple of weeks that I worked there, maybe the first day, I don't know. But my boss, Mike Pellock, who's been in the industry for a long time, very well known and well regarded. I can remember going and asking him, a question, and it would be, I don't know, we got to figure it out, because it was so new to all of us. It was pretty cool. So yeah,
that was in the cold
that's how I got started.
Steel?
Ended up moving to. So that was in the cold form steel. Yeah. We had just kind of converted. The programmers had done, the best they could with what they understood, converting the wood software over to design cold form steel. And it was a lot of hand checks on our end, calculating screw quantities, just a lot of different stuff, because it was trusses were brand new in the 90s out of cold form steel, our proprietary trusses anyway. Ended up moving to a fabricator customer of ours. They had offered me a job, and I'm young, I'm an engineer. I thought I knew everything, so I accepted the job thinking it would be easy, and I've been learning every day ever since.
Wow, very good. Thanks for sharing that. I have a few questions related to that.
Yeah.
What is the history of cold form steel trusses prior to Mitek's work?
So I know there were companies. Metalite was one of them. They still exist, but just under a different company name now. And they did C-stud trusses. And I guess there were a couple, maybe companies around the area, around the country, I mean, that did back-to-back C-stud trusses. I don't know how the design was done. I don't know much about it before I started, and that would have been late 90s, that probably 97, 98, when I moved, when it was part of Mitek's research and development department. And from what I understand, on the truss steel side, the Alpine product, it was similar. There's several other proprietary shapes that were around back then, and I think they all kind of had similar stories. But I do believe back-to-back studs were there, although the standards now for design really weren't really developed until the 90s. So anything before that time period, there just wasn't a good method of design. There weren't good guidelines for design. So I don't know how it was done before that. I do know, and again, this is a Mike Pellock thing, but one of the first forays into trusses that Mitek had was a project of some sort in Chicago, and the building official was calling Mike, because these are not structural members. This is not something that can support a roof, and it was new. Honestly, Mateo, I don't know the answer to that. I don't know how it all went down before the proprietary guys were doing it with software.
Very interesting. Now, take me back to wood for a moment. Two questions related to that. Do you know how long wood trusses had been in the industry, in terms of how long people had been fabricating kind of the modern wood truss that we're familiar with plates?
Yeah, so SPCA does a magazine every month, and Joe Canapel, who worked for Mitek, I think he was there back when I was there. I was just, in the cubicle pit, if you will, with the other engineers. And he was more in an executive level, but he has done some really, really neat articles on the history of the connector plate and when it was developed. And I want to say it was probably developed in the 60s or 70s, and software was right behind it. In fact, when I started with Mitek in 95, it was either 95 or 96, they had just moved to this Mitek 2000 software, which is a Windows-based software. They had used something prior to that. A lot of the fabricators still used it. I think it was called ACES, very DOS-based, very preliminary. So I think connector plates had been around for quite a while, but the technology really wasn't there to automate it like it's automated today, or even like it was automated back then. The software wasn't there to give the ability to design like we can, well, now, and then certainly back then. I think it made very, very large strides in the 90s and early 2000s, kind of that tech bubble.
Interesting. So tell me about, how come you switched to cold form steel and you never really looked back to wood? What's up with that?
Wow, that's a really good question, because I was having fun on the wood side. It was a great place to work. I had actually moved to the repair department, and there were 3 of us for that office that did repairs. And anytime a plumber would cut a truss member, or a connector plate would come out, or a homeowner wanted a vaulted ceiling, they would send it to us, and we would have to design a way to repair the wood truss. And it was really interesting work, as opposed to what I had been doing before, which was just reviewing truss designs. So probably, Mateo, the reason I wanted to jump over to cold form steel had nothing to do with cold form steel. I think it had a lot to do, well, probably because I had to wear a tie every day at that office, except Fridays. We had casual Fridays. A lot of this can end up on the cutting room floor when you go back this interview. But I think a lot of it was because I had moved to that repair department, and I was learning more about trusses, how they work, forces, just everything, and an opportunity to learn even more in a division that was doing something even just a little bit different was really enticing. Again, nothing to do with cold form steel. I probably didn't have any idea what cold form steel was at that point. We certainly didn't learn about it in school. Yeah, I think the just kind of the unknown and the opportunity to learn a little bit more, something a little bit different was what enticed me to move over there.
And we'll get into the AdvanT profile, but it seems like that's actually a bit of a theme for you, is that you like the challenge of developing novel engineering solutions.
Yeah, and I wasn't part of I didn't do the development. I was, riding the coattails of people that did back then. I very, very smart people at MyTech were doing some really, really cool things, and I just got to be, on the sidelines watching it and partaking and helping out where I could. But yeah.
Would you say that you do like the kind of the engineering and the process involved with like kind of R&D and development? Is that attracted you?
Oh yeah, absolutely. I think I like seeing opportunities for products that can do better. Where there's voids, and that's actually a really cool thing about cold form steel, because if you think about it, if you do anything with red iron, you've got to work within a catalog of shapes and sizes. But with cold form steel, you can see an opportunity, you see a void, see a market need, and cold form steel can be formed into whatever shape then is optimal for that market need. You don't have to meet that need with one of 24 shapes that may or may not work efficiently for that need. Cold form steel, you create the shape that makes the most sense for that, and I think that's kind of how all the proprietary shapes got developed.
Yeah, and I think that's interesting on two sides. I think the hot rolled steel sections are fairly mature now. They've been, people have been thinking about them for a century, basically, or maybe more. Whereas cold form steel, really, it's a novelty. And but the danger of it is, like, a lot of people look at cold form steel and they say, "Oh, I'm going to develop a new profile," but they don't know the history and the engineering. So it's really interesting that I think you have those two insights, where you have the history and the engineering, and you see so much of the versatile nature of the product.
Sure. Yeah, and the roll forming, that was something brand new for us. I knew you could get a cold form shape. I knew it could be formed, but there are some limitations even with what you can form, I guess, to some extent, although I think those limitations are fewer and fewer as the industry progresses, and probably could create almost anything at this point.
Yeah, that's the beauty of manufacturing and construction, is that even if the machine is expensive to design and build, once you figure out the process, the product becomes cheap.
Sure.
Because the process is repeatable, continuous. The unit cost of the equipment is relatively irrelevant over time if it's a very high utilization profile and product. So let's talk about that for a second. Tell us a little bit about what is the AdvanT profile? What is the need that you're filling? What did you see, and how did you kind of fill that need?
So I would say we developed the AdvanT profile, or started really focusing on that shape. The first round of tariffs that we had, I think it was 2017, 2018. There was a lot of fear in the steel industry. And I guess when tariffs went into place, and this is, going on 10 years ago, 8-9 years ago, I got to remember it exactly, but there was a big spike in steel prices. Similar to what happened with COVID, maybe not to the extent that happened with COVID, but it was a good spike that the steel mills were putting in, and I guess it was mostly tariff related, if I remember correctly. But projects just kind of froze. They were, owners were putting the brakes on because they didn't know what their costs were going to be. It was kind of a moving target. So until there was some certainty, a lot of these jobs just weren't moving. So we were a young truss manufacturing company. This is on the CF Steel side. And we were saying, just kind of looking like, okay, we're all chasing this finite amount of roof trusses, they have to be drawn, cold form steel roof trusses, and then we bid it, and we hopefully win our share of those and keep the plant moving and keep everything moving. And when those kind of the slowdown happened, when owners were not moving forward as much, we were looking for more work. And what we did was we took that opportunity to say, hey, maybe instead of chasing this existing market, let's see what makes sense to open up other opportunities. There's a lot of composite joists that are used for floors, maybe 4 or 5 floors, and then we're bidding this little mansard roof job along with 6 other cold form steel fabricators. Why can't we bid that floor? Hotels maybe are using deep joists that might not be the most efficient option, deep sea joist or proprietary flooring product that a lot of manufacturers had back then. And we said, there's got to be a way to use a cold form truss, to make a cold form truss that is cost effective in that application. The proprietary shapes that were out there at the time were intended, and I know this because of my history, they were intended for sloping roof trusses where you have a lot of depth, you've got big panels, so you need a lot of bending capacity, and depth is very beneficial in bending capacity between webs. And just everything in that design to make it efficient and cost effective in that sloping roof. Well, not everything, but a lot of the things that you put into that proprietary shape to make it efficient in that application, when you move it to a flat application where it's very shallow, very, very short panels, that section becomes inefficient because where its advantages actually work against it then when you get into that shallow, 12-inch, 14-inch, 16-inch deep product. So we said, all right, we know this isn't going to be cost effective. We're not going to be able to move into this market with any meaningful way using this shape. So what shape would work for that application? We needed something with a high center of gravity so that your effective depth as you get shallow is greater. You're not minimized. Your depth isn't minimized by the depth of your chord. So we needed a shallow chord. That worked against us with bending between panel points. Not a big deal. When you're shallow like that, even if your webs are 45 degrees, your panels are still very short. We needed a wide surface to attach sheathing to and move that center of gravity up, but we still needed enough of a vertical section to get enough screws in when we're connecting webs for high axial loads. And top chord bearing was a big thing on the composite joist that we were really focused on. So we needed a hefty enough section, enough steel in that section to be able to transfer the shear from the bearing to the webs, the webs in the truss, and carry the shear. But we needed a stout enough top chord that had the capacity to carry that shear. So I'm going to go backwards a little bit. The company that I worked for after MyTech was a truss fabricator, and my boss had the idea. It was a really good idea. He wanted to have an alternative to buying premium price proprietary shapes, the shape that we were accustomed of at the time. So he said, let's buy commodity C-stud and fold it and call it a shape. And it was a good idea. And that's where the T came from. And that T always stuck in my head. There's got to be a lot of advantages to that T. So when we went down this process, then at the company I was with, CF Steel, maybe 10 years later, that T is where I started. And it didn't work, as an efficient shape if you just fold it. And then there were no advantages to it because still have to have the equipment to buy commodity C-stud and fold it, roll it, whatever. That would be more costly than probably just a roll former to roll it from scratch. But that's where I started with, and we had to go through and tweak it. We needed more axial capacity. We needed more stiffness in the members of the section itself. So that's why we have a little bubble down there, but we still needed it tight enough that we could get double shear screws, and we had to make the flange big enough to add some capacity, but small enough so that we're not too wide. But that was the basis of that section, because he had suggested this T thing back in 2005, 2006, and that just, I loved that idea, and I didn't know why. And then when it came down to having to develop AdvanT, for this end use that we wanted, I thought, well, I'm going to start with that and see where that gets us. So that's how it started, and then we spent a lot of time tweaking it, creating sample shapes, testing those sample shapes, and without a roll former, it is very, very difficult to create some of those shapes. And I would come up with an idea. Hey, we need to add this stiffener here. We need to do this. And then our shop guys would have to figure out how to bend this steel to make it so that we could get a good idea of what would work before we invested in the roll former to roll form what would actually be the AdvanT shape. And and then take it the next step.
Is this the final form of the AdvanT shape? Do you think it will change, or is it you think it's pretty mature?
I feel like it's pretty mature. We have done some tweaking with it even after the fact, through software, checking the section, and I have not been able to improve upon it where for the amount of steel added or the amount of additional bends needed where it would make sense. The value proposition, if you will, the return for the extra steel or whatever does not increase the strength enough in the calculations I've run where it makes any sense. I think this is where this one is gonna land. I think this is what we're gonna stick with for a while. We've tried to do deeper ones. We've had a lot of interest in hey, can we use this on bigger industrial buildings, go 50, 60 feet and still stay pretty shallow? So we went down the road looking at, well, maybe right now the section is 3 inches deep. Looking at maybe a 5-inch deep or a 6-inch deep, and even a wider top flange. And then every calculation I do, we don't gain enough for the amount of steel that we have to add. So it's limited in that it's cold form steel. So I think those floor systems, those assisted living floor systems that are going to be 28 to 32, 33 feet, 16, 18, 24-inch deep, maybe in some cases. I think that's kind of where cold form steel and AdvanT in particular is going to shine. I think you get into those 50, 60, 70-foot industrial buildings with 4 or 5 foot spacing. Cold form steel, there's just not enough mass there. Certainly there are products that handle a little bit bigger, spans, higher loads than AdvanT does because there's more steel in the section. But even those, you get out to those much bigger spans, and red iron is probably makes the most sense.
Yeah. No, this is really interesting, and we'll get into like the application side of things in a bit. But just for my personal interest, what does it actually look like to test novel profiles? I know there's some softwares already that can simulate some of it, what, if you don't mind me asking, like what softwares do you even use to start to test this kind of stuff?
Well, so for just the testing I was referring to was actual testing in our plant where we would set up a test bay, if you will, and load it down with whatever we knew the weight of. We still do that a little bit. It's kind of fun. We've had some ideas for trimmable ends and stuff like that we've actually tested. But for software, when I say, hey, I've checked different sections, I 100% use CFS. CFS, it's very, very easy. Bob Waz's software, RSG software is the company. CFS is very well known. In fact, that was the first software that Mike Pellock had me install on my computer way back when I moved over to research and development to the steel framing division, so that I could double check what our truss design software was doing to make sure that, hey, it corresponded. But yeah, so that's how I would go through and check the different tweaks, adding stiffeners, removing stiffeners, changing depth, moving the stiffeners that are in our section, moving it up, down, making sure we have enough area for screw attachment, what web makes the most sense. All of that stuff I did, determining loads on the truss software and then running those loads through different sections using CFS. But then there is another software that I've started to use since then, Visual Analysis. It has the ability to pull in the sections from CFS, and then I can run actual trusses. One project that we're working on, they want 170-foot trusses, not carrying much load at all. But that's, and I'm not using AdvanT for that, but it gives me the ability then to actually run a simulated test. So there's some pretty cool packages out there to run testing on cold form steel, and those are the two that I primarily use. I think.
Have you tried using finite element analysis at all?
Yeah, I have not. We have had a company run finite element analysis with the AdvanT shape because they were using AdvanT and they wanted to test it, or they wanted to verify on their end that they were comfortable with it before they used it. It was a very high-tech company. So we have gone down that road, and frankly, the results were really good. With respect to how they corresponded to our the truss software that we would use to anticipate how it would react. So it was in line with what was already. Yeah, everything wasn't exact, but it was pretty impressive.
I was wondering if there was potential even for it to be over designed versus, because that's the challenge is
Sure.
Also coming up with something that isn't too conservative and wasteful of material.
Right. Yeah, no, and I was pleased with the finite element analysis because it did say it had a little bit more strength than what we were anticipating. It wasn't significant, wasn't a waste, but yeah.
Yeah, very interesting. Moving into this. Okay, so we've talked about the profile, the design process, how you got there. Let's talk about the application now in terms of like what building types. You've already kind of discussed it a little bit, but what building types, what individual applications, and this is really important to me because I'm a big believer that cold form steel is a tool in the tool belt. It's not inherently an all-encompassing system all the time.
Mm-hmm.
And I think I try to preach to the world that like there are some people who are trying to get you to use cold form steel in the wrong applications.
Sure. Yeah.
So what is sort of even comfortable or even a stretch of envelope of like, this is what you've seen it really apply to, this is where it shines?
So I guess from a market segment standpoint, where it has done very well, buildings that can't burn down. We're talking about cold form steel in general, right?
Cold form steel, and then the application of the AdvanT Truss.
So kind of my favorite line that I use when I go to these structural engineering conferences, different states put on SCA conferences where you have vendors. And so one of the things that I say pretty frequently is, when you're building a wood apartment building or a wood hotel, and then your project gets a little bit larger, maybe a little bit higher, or in an area where you have to be non-combustible, you have to go to type 1, type 2 construction, and then the normal step for engineers is to go to structural steel and concrete because that's what's familiar. But why would you go to that big, heavy, expensive product when there's a nice, easy in between? You're basically doing wood framing, but instead of using 2x6s, you're using 6-inch studs. Instead of using wood floor trusses and plywood, you can use AdvanT Trusses, cold form steel trusses, or joists, C joists if the spans allow, and a lightweight board like the Structocrete or one of the MGO boards. I'm a Structocrete fan for what it's worth, but it makes sense. It mimics the wood framing that you see every day on all of these projects, but you're just doing it out of non-combustible material. So you can go on that memory care building, you can go the higher hotel or the bigger apartment building, and you're not really changing a lot except for the material, what the material you're using is made out of, as opposed to completely redoing the whole idea of the structure with red iron and concrete. So in my mind, it just makes sense before you go to that material that's used in high rises, used in 10, 12, however many story large projects. There had to be something in between the wood framing and this red iron and concrete, and that's cold form steel. And then where it's also advantageous is seismic areas, because it's not so heavy that when you get into story shear, you're not moving a ton of mass side to side. You're a relatively lightweight product, which is going to improve that. We've had several projects where we've been told, hey, we've got to go something. We want to use wood. We can't use concrete because our soil bearing just isn't there. We don't have enough capacity. We need something light. With a cold form steel truss, light gauge steel walls, cold form steel walls, cold form steel truss, a lightweight board, Structocrete, 5 pounds per square foot. Our floor truss assembly is 13 pounds per square foot if you use our 2-hour rated UL 524 assembly, versus composite joists, which are probably going to be 60 to 70, or say 50 to 60 pounds per square foot, or hollow core or composite deck. You're probably looking at 70 to 80 pounds per square foot. So you take that 13 pounds per square foot versus 60 pounds per square foot, was that 47 pounds? And then you take that over 5 stories, you're adding a lot of, are you adding or taking away, however you want to look at it. If you're using a truss versus a composite deck or a composite joist, you're removing so much load, per square foot, 40 pounds, then that your first floor walls don't have to support, your first floor beams don't have to support, your footings don't have to support, your soil doesn't have to support. All that dead load that's not doing anything except adding mass, adding weight to your structure. That didn't answer the question at all, because you said what building types, but
that's incredible. You've never explained this to me, that basically one floor of, say, a composite system is equivalent to like 5 floors weight of the AdvanT system. I mean, that's actually mind-boggling a little bit, how much less weight you're talking about.
Right. And then you go, as you go higher on a building, your lower level, you might see a project 6-inch studs, 3-inch flange, 12 gauge, doubled up. Well, that's because it's supporting all that weight of all those floors above, versus a option. It's a option that would work in type 1, type 2 construction, where you have to be non-combustible.
Yeah. So okay, this is great. And I do, for future listeners, I do want to just mention building types. So I've got hotels, I've got apartment complexes. We've personally used it in like a shopping center-esque type build where they wanted to do the roof. I've heard of podium replacements. So instead of using bar joists like in a factory setting, they can use AdvanT Trusses for a lighter system. What else? Any flat floor system or flat roof that's not outrageously large. What other systems have you seen it used in?
So one thing that I probably had never heard of prior to 2 or 3 years ago is dust covers, where a big industrial building might be getting updated or converted, and they're putting in offices, and they need big span ceilings. And our trusses have been pretty popular for things like that. Mezzanines, where you're putting in a second floor mezzanine, you need light storage up there, but you don't want to pump in a bunch of concrete, add a bunch of weight to your existing building. The AdvanT Truss and Structocrete have been a great alternative for that. Just bring in trusses, set them on your walls, put down the Structocrete, and your capacity. You can easily accomplish that 125 pounds per square foot live load capacity requirement for light storage without having to add 40 pounds per square foot of metal deck and concrete. That's been a really good one. We did, one of our customers converted a ceiling in a casino. It was actually a movie theater that they were converting to a casino, and they wanted to put a fancy ceiling in there. So they used trusses to drop the ceiling a little bit and hang whatever ceiling material they needed to hang that. So I would call that adaptive reuse, I think would be the term for that, where you're using it, taking a building and then converting it to something else. Job here in Charlotte, I'm in Charlotte, North Carolina. Job here was an old Model T factory that they were going to convert into offices and restaurants. And they wanted to put a second level in the majority of the building without knocking out a bunch of concrete to put footings and metal decking and or joists and pumping in concrete. So they used our trusses, they used the lightweight board, and our family went there a couple weeks ago because one of the places that has been open is now a pickleball place, and we just sat on the balcony, which was made out of our trusses, and watched people down below playing pickleball while we enjoyed our lunch. It was pretty cool.
That's awesome, and it's. I mean, talking about the broader cold form steel world, it is really cool to see how cold form steel is both this primary structure. It can be a primary structure, but it can also be just such a versatile secondary structure for renovations, for additions where, you don't want to necessarily rebuild the foundation, reinforce everything, to a crazy extent. So you can just put like H steel and accomplish so much.
It can definitely simplify a lot of things.
Yeah, fascinating. Very good. Well, I want to wrap up with a couple questions. Just you have a lot of experience in the market, and from your experience, where is this market heading? Do you see an increase in activity? Do you see it? I mean, be honest with us. Do you see it kind of a steady state? What's the future of the market?
The future of construction in general, or the future of CFS? I assume you're talking about the future of cold form steel.
The future of CFS in construction.
Yeah, so it's definitely gaining popularity, especially as more and more players get involved. You have a lot of roll forming companies are coming in, selling their roll formers for panels, for trusses, and really just selling studs in general. There was one point in my life where I would look at that as, oh no, more competition. That's all we need is more competition. But really, it grows the market. As there's more people preaching the good news of cold form steel and how versatile it can be, and how you can use it in these different applications. I'm sure the applications that I always talk about: hotels, assisted livings, multifamily, smaller retails, like you mentioned, with a flat roof. Maybe you don't need to go to bar. There's no reason to go to bar joists for that 40-foot span. the dust covers, the mezzanines, which markets that I never would have thought of. There's probably dozens more markets, and it might that I will never come up with, but maybe one of these other companies, maybe that's something that they focus on, and they just open up, they grow the pie then for everybody to go after. So I think that the future, because there's so much more interest, not only from architects, engineers, but from other manufacturers, I think it's going to go a long way to helping us as an industry get more recognition and more opportunities. So yeah, I think it is definitely not. I don't know if the growth is going to be exponential, but I think it's definitely going to be steady. It's not going to be flat. I really, just from what I've seen today, with opportunities from different parts of the country, I'm pretty optimistic that the future is looking really, really strong for cold form steel. Just the versatility and high strength to weight ratio. There's a lot of galvanization, so it doesn't rust. A lot of things doesn't get mold, doesn't grow mold, doesn't burn. So many things going for it. So many projects. I've seen so many more projects over the last couple of years where the owner just wants a higher quality product. They just don't want to use wood. They can save some money using wood, but if I switch to cold form steel, it doesn't cost so much more that it doesn't, if I'm going to own this project, I want it out of this product so it lasts, so I don't run into problems down the road. And then with insurance savings, I've heard, I don't know the specifics of it. I've heard varying levels of insurance savings, but a lot of the numbers I've heard have been significant, where it actually brings cold form steel back into the realm of what you're going to pay for conventional wood framing. So I think, I think that's going to continue to get better and better, and the opportunities are going to continue to grow.
Yeah. Just to add to that, if you're looking, let's say, building a larger commercial structure, or like it could be a hotel or something like that, and historically, just to use concrete and bar joist or similar, composite deck products, it's expensive. It's really expensive. The amount of concrete, the need to, once you're done with your structural, your red iron frame, you still have to come back in there and put studs to get a wall. Like you've only done half of the process and you've already spent so much money. I think there's tremendous advantage, like you already said, for those type 1, type 2, where in many cases now you're only seeing one trade, framers, cold form steel framers, who can do walls and can set trusses and can basically do everything and dry in that building without ever needing to call an erection crew and getting welders and prefabricated steel structures onto the site. So I think that's a huge innovation that's gaining momentum. And one of the amazing things in the U.S. is because of the light wood framing has kind of set the tone for fast to put up buildings, right? And more affordable housing historically. And so now this is like a best of both worlds, where it's got the properties of steel, but it's not a complicated, slow process like steel fabrication and erecting. So that's a really interesting paradigm shift that I think we're seeing here as well.
Agreed. Yeah, I think you're in a pretty good spot. If the market was looking this promising back when I was your age, wow, I mean, sky would be the limit.
Yeah. It's a good time, and it's interesting also to think. I think what you've done and what you've modeled, and this is why I'm so glad I got you on a call here, is because I think more people are going to realize we can push the envelope of the efficiency of cold form steel and do things with it that you just can't do with wood. You can't come up with. I mean, they are very creative. I'll give the wood guys some credit. They are very creative. They have some great solutions, like the composite joists and things that they're doing, and mass timber. This is not a wood versus steel competition. It's just the reality of working with an organic versus an inorganic building material. It's like why you don't see wood in cars is because they're looking at how to manufacture it, and they're looking for replicatable, high tolerance, repeatable systems and processes that can drive down costs. That's what we're looking at, really. My company, US Frame Factory. And I think it's hard to replicate that with wood products like you can with steel products.
Yep, agreed.
So let me just ask you one more question that I have here, which is the future of construction as a whole. I mean, this can be this is not even a question steel, wood, concrete. Like what is where is the way we build, the way codes are moving, the way the processes between architects, engineers, how is that changing? Where do you see it moving? Let me add one more bit to this, which is, even the fact that you've come up with a brand new, never heard of before profile and put it in the market, that kind of that intimidates me, like the gravity of doing something like that. How can you talk about that in context of construction and the ability to innovate in it?
Oh, that's a good question. So how I picture the future of construction, I think there's a lot of people out there that a lot of companies out there that over time have tried to make big changes in construction, and I don't think construction's in general open to that. There's been companies that have started up, a lot of money backing them, and have pushed a lot of maybe modular. Everything, we're going to build everything this way. In fact, that happened with cold form steel in the residential section probably a couple times. But I can remember maybe 20, 25 years ago, a big steel manufacturer had a division, and they were going to convert everything to cold form steel. And construction just doesn't accept change at that level, at that magnitude, that well. And it's going to resist. But where I do see gains is the smaller companies, with small changes that are innovative. Maybe not, instead of making everything this modular construction, maybe I'm making my bathroom pods modular and putting those and saving X amount of time. And I think those small changes are what we're going to continue to see in construction. That's what we've seen over the years. And that, trusses versus rafter framing. It's not, I'm going to change the entire way you build the structure. I'm going to start, help you start using trusses on projects where it makes sense. And I think residential that has moved from primarily rafter framed in the 70s, 80s, maybe even before that, to primarily trusses today. And it wasn't an overnight change. It was a small change. Wood wall panels in general, wood or steel. I think we're seeing a shift where the majority of projects probably are going to be panelized now. But again, not overnight. Panelization's been around for decades, and it didn't really take over, or it hasn't taken over. It probably won't, but it's going to continue to be more and more popular, gain more market share. So I think that's what we're going to see. Products like AdvanT, I think we've got for floor systems, for light gauge cold form steel floor systems, I think we have the best product out there right now. I'm sure that could change. Somebody promote something different, but it's slowly moving the needle on some composite joist jobs, some hollow core concrete jobs. It's not taking over. It's not moving that quickly. So I think that's how construction is going to continue to go. But over my 25, almost 30 years, probably, if I go from then to now, it's pretty dramatic. But at no point in time over my career has anything been, a dramatic shift. But if you look at the progress we've made, we're always going to make progress. So I would always encourage, hey, try something new. Let's figure out, a better way to do this process, because it is accepted. or it can be accepted. It just might take a little bit of time. Be patient. But yeah, things will continue to improve.
That's awesome. So much to think about there. One thing that struck me is a lot of the best technological advancements in construction, if you look at them, like at first glance, they don't look different from what was already being done before. Like if you look at some of the new like zip system type OSB, it's just OSB. It just has the water barrier on it.
Right.
Or you look at Structocrete, and that's just it's a floorboard, but it's a slightly different material makeup and system, and it brings a lot of advantages. But ultimately, they didn't reinvent how you build floors from like completely. They just added another layer to it.
They reinforced concrete in a panel form. Yeah, absolutely.
Yeah, so that's a really great observation, and a lot of people try to treat it like electronic technological advancements where it's like you blink and the next year it's like your phone is antiquated now. Like, so that's a very I personally enjoy the industry for that reason, because it's you can win with patience instead of instead of winning by force or magnitude.
Right. Yeah. Or as we've seen with a lot of the companies that have tried it, money. I mean, we probably have little guys have just as much opportunity to move the needle as the big guys, and that's pretty cool.
I mean, you basically did all this design work pretty much by yourself, didn't you? Or was there more of a team involved with the development?
No, I mean, the specifics of the section I probably worked on mostly, but as I described through my history, I had a lot to build on. I was pretty high up before I had to jump off, or a lot of people had contributed to things that just kind of stuck with me over the years that helped it make sense. So by the time it was, we were ready to create a section for our own truss product, I didn't have that much further to go.
Right. That makes a lot. It required your experience, but I guess it's very fascinating that it didn't require, like a huge design team of multiple engineers, all kind of tirelessly working, chipping away at a new design.
Right.
It was more of a culmination of several people's kind of various thoughts culminated in you figuring out the magic for that next profile. Well, look, I'll close with this. I mean, first of all, thank you so much for being taking your time to be with us and talk to us about this. Do you have any advice for people interested in the industry, interested in fabricating trusses?
I mean, if you're interested in it, that's half the battle. I mean, if it's something, have fun with whatever you do. And if it's something that interests you, by all means, jump in. There's a lot of people out there to support. Boy, I can still remember, I mean, the couple of names that I mentioned that influenced me at MyTech, and then at the first company I worked for. And I could go on and on and on. People who just go out of their way to try to help other people grow, and just in an effort to grow the business. And really a lot of it, I think a lot of the people I dealt with were just out of the goodness of their hearts. They just want to help other people succeed. And there's a lot, if it's something that you're interested in, don't be afraid to ask around. You're going to find more people than not that want to help you succeed. And it's a neat business to be in, and we accept anybody that want to dive in with us.
Yeah. Well, you didn't ask for my advice, but I advise anybody who wants to get into the business is look past the first link you find. Like, look a little bit deeper to see who's actually engineering the real systems. And I think so often people see kind of the best marketing companies in the space and don't see the best engineering companies in the space.
That's fair. Very fair. Yeah, thanks again for having me. This was great.
Yeah, thanks, Tim. I'm going to stop our recording now, and thanks so much for being on this time with us and this call.
You bet.